The melting point apparatus consists of two test tubes with different diameter. By building a paper sleeve for the small test tube, we can position it right into the center of the bigger one. This creates a layer of air between them which can act as a bit of an insulator. Air and all gases are not good at conducting heat because gas molecules are far apart, not in contact with each other as in liquids and solids. This insulation will prevent any material from cooling or heating too fast when it is placed inside the smaller test tube. A small Erlenmeyer flask is used to hold the test tube when we transfer substances into it and when we weigh it. You will already be provided with a small test tube containing 10 grams of lauric acid, and your first job is going to be weighing the mass of unknown substance that you will be provided with. So you weigh the vial in which the substance is contained before and after transferring that substance into the small test tube. So when the two substances have been combined, we place the paper sleeve around the small test tube and insert it into the larger test tube again, and then the test tube gets clamped in order to be lowered into a hot water bath. Setting the heat on the hot plate to about 320 degrees Celsius should allow for a beaker of this size filled with this much water to heat up to about 80 to 85 degrees Celsius, which is good enough for a quick melting process. The magnetic stir bar will contribute to an even temperature distribution inside the beaker with the water, and it will then take a couple of minutes to melt the solids inside the smaller test tube. Watch it closely. It looks very similar to what happens right now to the polar ice caps due to global warming. If the solute, which is your unknown, does not dissolve fast enough, you can help it along and use your thermometer to stir the mixture a little bit to speed up that dissolution process. When every crystal of your unknown has dissolved, you raise the test tubes up from the hot water bath, and after a minute or so, you can transfer the test tubes into the test tube stand. Let it cool a little longer until it is not too hot anymore to touch the top of that test tube, and from now on you continue stirring it with a thermometer and record the temperature in regular intervals. The temperature of your solution will first fall relatively fast and then slower and slower as you approach the freezing point of your solution. You continue to record these temperatures in 30-second intervals until you're near that new depressed freezing point, and you will notice that the solution becomes slushy. And when this slush has established throughout your solution, you record your final depressed freezing point temperature, and you're basically done. Clean up. The thermometer is removed from the slush, wiped down with some paper towel, and then placed into an Erlenmeyer flask. We will later wash it down with some acetone. The test tube containing the slushy solution will be placed into a stand on top of a shelf on your lab bench labeled used freezing point tubes. And there you'll also find a glass beaker for the used vials that have contained the unknowns. And finally, you wipe down the rest of the equipment with disinfectant wipes, and then you can go wash your hands and leave the lab.